Yeah, so we were discussing redox reactions. Okay, so we are done with balancing of redox reaction and finding equivalent weight, and for finding equivalent weight we need to know how to calculate n factor also. Okay, so how can we calculate n factor? So for elements, if it is gaining some electrons, the number of electrons gained by that element will be considered as its n factor, or if it is losing some electrons, the number of electron lost by that element is its n factor. Okay, if for an acid, number of H plus ions released will be its n factor. For base, number of OH minus. Okay, and next, for example here KMnO4 is there. I am taking this permanganate ion, converting into Mn plus 2. So what is the change in oxidation state? So plus 7 here for manganese, converting into plus 2. It means how many electrons gained or lost? Gained. How many? 5 electrons. So its n factor for this process will be 5. So now if they ask what is the equivalent weight of this manganate ion, permanganate ion, what is the equivalent weight of this permanganate ion, if they ask, what you will do? Take its molecular weight by its n factor. That will be giving you the equivalent weight of permanganate ion. Okay, like this. Take number of electrons lost or gained during that process will be its n factor every time. Okay, next. Here we are discussing about titrations. So first one, titration using potassium permanganate. What is it? KMnO4, potassium permanganate. Okay, so now potassium permanganate act as a oxidizing agent. What I am saying? So using this we can able to identify, see, it's act as a strong oxidizing agent, acts in both acidic as well as basic medium. And what is the color of this potassium permanganate? Purple. What is the color? Purple. So since it has a purple color in this KMnO4 plus 7 oxidation state, whenever it is participating in reaction, if complete potassium permanganate is reacted, then there is no potassium permanganate. Now if it is completely reacted means now color will disappears. Okay, it means by looking at the color change we can able to identify where is the equivalence point or end point of that particular titration. So I can say potassium permanganate can act as self indicator. What is that? Self indicator. Okay, right. And when we are doing this reaction in acidic medium, like when we are doing the titration in acidic medium, we should preferably use sulfuric acid. What we need to use? Sulfuric acid. We should not use HCl. Why should not we use HCl? Because this use of HCl is avoided as KMnO4 oxidizes this Cl minus from HCl we have now. From that Cl minus will be oxidized to Cl2. So it should not be like whatever the acidic medium we are making, that reagent should not involve in the redox process. Okay, so if I use chloride, HCl, hydrochloric acid, that chloride ion will participate in the reaction. That should not be happen. So that's why we are preferring sulfuric acid over HCl. Okay, right. So now yesterday I have given some questions related to this. Say I have KMnO4. I can use, now using KMnO4, that redox reaction method, I can estimate what is the oxalate ion concentration, because we know KMnO4 can convert or can oxidize oxalate ion or oxalic acid to respect to carbon dioxide. Okay, so here KMnO4 in acidic medium converts into Mn plus 7 to plus 2, and oxalate ion here carbon is in plus 3 oxidation state, converts into CO2 plus 4. Okay, so this is what happens here. Okay, now see, this permanganate ion, potassium permanganate is converting from plus 7 to plus 2, means what is this process? Reduction. And what about here? Carbon is converting into plus 3 to plus 4. This is oxidation. Okay, so now the species which is undergoing reduction will oxidize others. So now this species is oxidizing the other one now, so I can call it as oxidizing agent, and this species undergoing oxidation and reduces others. It means this should be called as reducing agent. During redox reaction there will be one oxidizing agent, one reducing agent. Okay, one oxidizing agent, one reducing agent. So now whenever we are doing titration, it follows law of equivalence. What is this law of equivalence? The number of equivalence of oxidizing agent will be equals to number of equivalence of this reducing agent. So I can write number of equivalence of KMnO4, that is oxidizing agent, will be equals to number of equivalence of reducing agent, that is nothing but oxalate ion. That's what I am saying. Okay. So now instead of writing number of equivalence, you can write number of its normality into volume of this oxidizing agent will be equals to normality into volume of this reducing agent. You can use this formula, or you can also use number of equivalence as n into n factor of this oxidizing agent and n into n factor of this reducing agent. Or you can also use one as n into n factor, the other thing as normality into volume. This should be expressed in liters. This should be expressed in liters. If it is expressed in ml, divide by 1000. So this is what you need to make. Okay, right. So if you want, I will give you one question. Tell me your answer. Number of moles of KMnO4 needed for complete oxidation of 2 moles of ferrous oxalate. Tell me. Number of moles of KMnO4 needed for complete oxidation of 2 moles of ferrous oxalate. What is your answer? So what I told you, here KMnO4 we have and ferrous oxalate. So what I told you in the last class, so +7 converts into +2 here, and iron here +2 converts into +3, and oxalic acid from +3 converts into +4 CO2. So here this ferrous oxalate completely undergoing oxidation. So what is the n factor change, tell me, in this oxidation process? See, iron from +2 to +3, it means n factor with respect to iron will be 1, and with respect to carbon 3 is converting into +4. It means what is the n factor change? +3 converting into +4 means 1. For each carbon 1, 2 carbons are there, so 2. So n factor total will be 3. So now what about this manganese? +7 is converting into +2. It means n factor here is 5. So what I told you, this is an oxidizing agent. So n into n factor of oxidizing agent will be equals to n into n factor of reducing agent. Okay, tell me here how many moles we required, we need to calculate. N factor is 5, and this side number of moles given is 2 and its n factor is 3. So it will be 6/5. Okay, like this we are doing. Similar to these, we have one more titration method, that is titration using potassium dichromate. What is this potassium dichromate formula? Tell me. Tell me what is potassium dichromate formula? K2Cr2O7. Okay, so now see here it can act as oxidizing agent, it is also, because chromium here is in +6 oxidation state. What is oxidation state of chromium? +6. Okay, so now whenever it is undergoing reaction in acidic medium, so it will be converts into Cr +3. So +6 is converting into +3. So what is the oxidation state changed? 3. Oxidation state change is 3. What is the N factor if I ask? 6. Why it is 6? So for each chromium 3, 2 chromiums are there, 2 3s is 6, like that. Okay, so N factor change here in this process will be taken as 6. Okay, so now when we are doing acidification, it means reaction is taking place in acidic medium, we are saying now. So you can use sulfuric acid and HCl can be used. Okay, so because potassium dichromate cannot oxidize HCl, but in KMnO4 it can oxidize Cl chloride ion to Cl2. Okay, there you should use only sulfuric acid. Okay, and here you can see potassium dichromate is less powerful oxidizing agent than potassium permanganate. Okay, remember that statement. And here we will be using indicator. So what is the indicator? See, external indicators are used in this titration. So here we will be using potassium ferricyanide like K3 FeCN6. This is the external indicator we will be using, or we can also use diphenyl amine. It's an internal indicator. These are the two indicators we can prefer in potassium dichromate titrations. Okay, so now look at this is what we have did next. Answer this question. This is dichromate only now, Cr2O7, like this we have. And what is the metal we have here? Iron, +2. So now what I told you? 15 ml of aqueous solution of Fe +2. This is having 15 ml. Okay, in acidic medium, completely reacting with 20 ml of potassium dichromate having concentration 0.03 molar. Okay, so now what they are asking? Aqueous, the molarity of, it means the concentration of this Fe +2 they are asking. So what you will be doing here, tell me? So here Fe +2 will convert into Fe +3 and +6 oxidation state of dichromate will be converts into +3, like this. So now find its N factor in both cases. Find its N factor in both cases. See, +2 is converting into +3 means N factor will be 1. And here chromium +6 is converting into +3. It means like 6 is converting into 3 means electrons gained is 3 by 1 chromium. How many are there? So 6 N factor. Okay. So now what I can say? Number of equivalents of this Fe +2 will be equals to number of equivalents of dichromate, like this. Next, you can use normality into volume of dichromate and normality into volume of this Fe +2 ion. So here they have given molarity. What is the relation between molarity and normality? Normality equals to molarity into its N factor. So what is the N factor for this dichromate? 6. 6 into what is its molarity given? 0.03. Volume given 20 ml. And this side, what is its molarity? We need to find. What about its N factor? +2 is converting into 3 means N factor is 1. And how much volume it is? 15 ml. So what you can make here? So now molarity will be how much? So this will be 0.03 means you can write this is 3 times, this is 4 times and this is 0.01. So this will be 24 into 10 power minus 2. This is the molarity of Fe +2 ion in the solution. So dichromate titration is also done. So what is the indicator we can use in dichromate titration? Potassium ferricyanide. Potassium ferricyanide. Remember that. So what is the answer you can take here? 24 into 10 power minus 2. And after this, we will discuss about iodometric and iodimetric titration. There are two types. One is iodometric and another one is iodimetric titration. Okay, so when I am saying iodometric titration, it is an indirect titration. What I am saying? Indirect method, and this is a direct method. Okay, so first of all, here you can see iodometric means here we will be using iodide ion. What we are using? So this iodide ion, nothing but iodide ion is nothing but something like Ki solution will be used. You can consider if it is Ki, K plus, I minus. So this is what we are using here. Okay, iodide ion. Now this iodide ion is used for finding strength or concentration of some oxidizing agent. So now what this oxidizing agent will do? This oxidizing agent will oxidizes this iodide ion to iodine. What it will do? Iodine, and this will be forming some products. Okay, there is nothing to discuss about products. So just oxidizes this iodide ion, whatever the oxidizing agent. Here we are taking oxidizing agent now, its strength we are going to calculate. It means its concentration we are going to calculate. Okay, so how we are going to calculate? So whatever the iodide ion we have taken, that will be converted into I2 with the help of oxidizing agent. Now this iodine further titrated with some hypo solution, Na2S2O3 is called hypo. So now what happens? Again that will form iodide ion. Okay, so now what is the use of doing all these things? S4O6 is formed. Okay, so what is the use of doing all these things? Here what I told you, we don't know what is the concentration of this oxidizing agent. That is what we need to calculate. So simply you can use that equivalence method. Equivalence of this oxidizing agent will be equals to equivalence of iodine formed, that will be equals to equivalence of hypo used. Now here hypo is a standard solution. It means its concentration and volumes I know. Using this data, that is equals to iodine, that is also equals to oxidizing agent. Simply I can write, if these two are equal, I can make these two are also equal now. So equivalence of oxidizing agent equals to equivalence of hypo. So using that method we can able to calculate. I will show you one question. Okay. Now when it comes to iodimetric titration, here direct iodine is taken, I2 is taken. So now this will be used for finding the concentration or strength of a reducing agent. Okay, so now what it will do? This reducing agent will convert our iodine to iodide ion. It means oxidation state is how much here? 0. Now it will be converted into iodide ion. So 0 to minus 1 means what is happening here? Reduction is happening with the help of this reducing agent. So some product will be formed. So now what we know? We need to know concentration of this reducing agent. So simply I can write equivalence of this reducing agent will be equals to equivalence of iodine used or iodide formed. Okay, so now using the data whatever we have here, we can able to find the concentration of reducing agent. Like here generally we will use it for calculation of concentration of something like hypo solutions. So you will get more clarity when you look at the question. See now in both of these titrations we will be using starch as an indicator. What is the indicator? Starch in both of these titrations. Okay, so I will show you one question. Look at this question.
The starch is used as an indicator of what does it indicate?
It will show the color change. like iodine, like blue color. You just observe. Take one potato at your home. Okay, potato you take. You just add some salt. Which salt? That nowadays on salt you can see iodized salt is mentioned on salt packets. You take that salt and just sprinkle on your potato. You will see some at least slight color change, because very low concentration of iodine will be there in that iodized salt. So that will show the color change. Okay, it will convert into light blue. Yeah, like blue. Yeah. Next, look at here. 20 ml of 0.02 molar hypo solution is used for titration of 10 ml of copper sulfate. It means hypo means Na2S2O3. So this is the solution used for titration of copper sulfate in presence of Ki. It means you take copper sulfate first. Okay, in presence of what? Ki. Okay, so now Ki, using starch as an indicator. What is the molarity of Cu plus 2 ion they are saying? So first of all, this copper sulfate solution will react with this Ki, and what happens here is Cu plus 2 oxidation state is there now, that will convert into Cu2I2. It is nothing but Cui. So what is the oxidation state in this case? Plus 2 is converting into plus 1, and along with this iodine is released. What is released? Iodine is released. Okay, so now that released iodine will react with our hypo, Na2S2O3. Okay, and forms NF2S4O6.
So CuSO4 is oxidizing it.
Huh?
CuSO4 is oxidizing
It is undergoing reduction, means it is acting as oxidizing. So simply here I can write equivalence of copper sulfate will be equals to equivalence of iodine released, that is equals to equivalence of hypo, Na2S2O3. Okay, so simply what they are asking, see, 20 ml of hypo is given having its concentration 0.02. See, hypo oxidation state is plus 2, converting into, here plus 2 is converting into 2.5. What is the change in oxidation state? 2 to 2.5. It means what is the N factor? See, what is the N factor? 2 are there now. So 2 into 0.5. 1. What is the N factor? 1. So I can write here its N factor is 1 and its molarity is 0.02 and its volume is 20 ml. Okay, and they are asking what is the molarity of copper sulfate. Okay, and given volume is 20 ml copper sulfate is given, 10 ml of copper sulfate is given, and they are asking about its molarity. See, plus 2 is converting into plus 1. It means what is the N factor change? 1. Okay, that's it. So you can remove 0, 0. So molarity of copper sulfate will be 0.04, or you can write 4 into 10 power minus 2. So you can write in this bracket as 4. This will be your answer. Okay, so this type of questions are on iodometric titrations. Okay, right. See what happened here. See, I have taken Ki. It means I need to calculate copper sulfate concentration. It means what is our oxidizing agent here? Copper sulfate, because it is oxidizing iodine, iodide ion to iodine. That released iodine is reacted with hypo. Okay, so complete process, in this complete process what we did, we have calculated concentration or strength of this oxidizing agent. So which method it is? Iodometric or iodometric? Iodometric, because it is an indirect method you are seeing right now. See, we haven't directly calculated what is the concentration of iodine, concentration of copper sulfate. We just treated it with Ki.
Iodometric is oxidizing agent, something different. That's reducing it.
In this method, iodometric method, we can able to estimate concentration or strength of oxidizing agent. In which method? In iodometric. In iodometric, we can able to estimate concentration or strength of reducing agent. That's it. Okay, right. Next, one more thing here. Will you able to balance this question once? Good evening, Tanzila. Yeah, so will you able to balance this one? So those who are new to this channel, just click on the subscribe button if you are new. Yeah, so try to balance this equation. Balance the redox reaction by half reaction method. See, half reaction method they will say, or instead they will say ion electron method also. What is that? In this method, you first of all write the equation they have given, Br2 H2O2 and BrO3 minus plus H2O is given. So now first of all identify their oxidation state, here 0, here -1 for oxygen, and from bromine here it is +5 and this is -2. You have written the oxidation state. Now identify the oxidation half reaction and reduction half reaction. See, 0 is converting into +5, it means it is oxidation. -1 is converting into -2, it means it is a reduction half. So take this reaction individually. So oxidation half, here I am writing oxidation half reaction. Tell me what is that? Br2 converting into BrO3 minus. Okay, what is the reduction half reaction? Tell me. H2O2 converting into H2. These are the oxidation half reactions, reduction half reaction. Okay, after doing this, so just +5 is converting into +0 is converting into, 0 is converting into +5. Okay, so how many bromines are there here? 2. This side also you multiply with 2, so therefore it will be 2 BrO3. After doing this, 0 is converting into +5 means how many electrons gained or lost? +5 means lost electron. How many? N factor you find. So 2 bromines, each bromine is converting from 0 to +5. It means 10 electrons. So here 0 is converting into +5 means I can say 10 electrons are released here. Okay, is this clear up to here? After doing this, is that oxygens are balanced in this reaction? See, bromines are balanced but oxygens are not balanced. So balance oxygens by adding water molecules. Where do we need to add water molecules? To the deficient side. So left side here. How many oxygens are there here? 3 to the 6. So 6 water molecules you can add. It gives 2 BrO3 minus plus 10 electrons. After doing this, what is the deficient site again? See, here hydrogens are there but product side no hydrogens. So we need to add H plus ions. How many we need to add? How many we need to add? Tell me. 12. Why? Because 6 to the 12 we have. So you can add Br2 plus 6 H2O to BrO3 minus plus 10 electrons plus 12 H plus. Okay, done up to here. So this oxidation half reaction is balanced. Now look at the reduction half reaction. Look here how many oxygens are there. So you can multiply with 2. It becomes 2H2O. After that minus 1 is converting into minus 2. It means how many electrons it is gaining or losing? Minus 1 is converting into minus 2 means it is gaining. How many it is gaining? H2O2 minus 1. See, each one required 1 electron, so it will be H2O, it will be like this, minus 2, okay? Okay, and after this, just check what we can do further. 1 minute. Yeah, just check what we can do further. How many electrons here gaining? 2 electrons. Then next, oxygens balanced, hydrogens balanced. Hydrogen balanced or not? 2 only, there is 4. So what I can make here? I can add 2 H plus ions this side, so that both side becomes 4 hydrogens. Okay, so everything is balanced in this also. After doing this, look at the oxidation half, reduction half. The number of electrons gained and lost should be same. So, but are they same here? It is 10 electrons, but here it is 2 electrons. Are they same? No. So, in order to make it same, multiply with suitable integer. See, if I multiply this equation with the number 5, what happens? 5 H2O2 plus 5 to the 10 electrons plus 10 H plus ions gives 10 H2O. This will be the equation we will get. Okay. After getting this, add both equations, these two, oxidation half and reduction of Br2 plus 6 H2O, 2 BrO3 minus plus 10 electrons plus 12 H plus, and here 5 H2O2 plus 10 electrons, 10 H plus gives 10 H2. See, see, reactants at 10 electron, products at 10 electron removed. Reactants at 10 H plus ion, products at 12 means 2 more are remaining. And the next, reactants at 6 water molecules, products at 10, it means 4 H2O is remaining. So what is the net reaction we have now? Br2 plus 5 H2O2 gives rise to 2 BrO3 minus plus 4 H2O plus 2 H plus ion. That's it. Do we have any electrons in the equation? No. So this will be the final equation or final balanced equation. So this is how you need to balance using ion electron method. Okay. So whenever you have disproportionation reactions, you need to follow ion electron method, that will be more effective in disproportionation reaction. Okay. Normal reactions are there means, normal redox reactions are there means, just go through oxidation method, oxidation number method, that will be easy. Okay. Yeah. Okay. So next you just open your module and try questions from that. If you have any doubts, you can ask me from redox reaction. Okay. Let me check any PYQs are still remaining in this.
So this method can be applied to any reaction?
You can apply, but most suitable for disproportionation reaction. You can easily answer this question, I hope. Tell me. In neutral or faintly alkaline medium, KMnO4 oxidizes iodine to iodate. The oxidation state of manganese will be plus 7 to plus 4. In what? In which medium? Neutral or faintly alkaline. If it is like strong basic medium, plus 6. You got to know this already. Okay. See, when I say a species is undergoing, some X2 is there, undergoing disproportionation like X minus plus XO3 minus is formed. So what is the n factor of this X2 if I ask? What you should take is, you take N1, N2 by N1 plus N2. What is this N1, N2 here?
N1 is X minus.
What is the n factor of, see, X2, it means 0 converting into minus 1. It means oxidation or reduction?
Reduction.
So reduction, na? So this is reduction method. So what is the n factor in this reduction method?
Minus 1.
See,
R2.
2 converting into minus 1. It means 0 is converting into minus 1 means 1 electron is gained by 1 x. So it will be total n factor is 2 in redox. Now similarly you tell me for this oxidation, here what is the charge? Oxidation number is plus 5. So 0 is converting into plus 5 means how many electrons gained? Last 0 to 5 means 5 electrons by 1x. There are 2, so 2 into 5, total 10. So you consider in this reduction method, you consider this is N1, in oxidation method as N2. So take here N1 is 2, N2 is 10, so 2 plus 10. So 20 by 12 is the n factor of this X2 in this disproportionation reaction. Okay? Yeah, like this you need to calculate. Is this clear or not, finding n factor for disproportionation? What is the formula?
N1 into N2 by N plus.
N1 plus N2. Okay, next. Can you do this? What is the equivalent weight of Mn placed in the following reaction? This is which reaction it is? Which type of reaction it is? Disproportionation. Plus 3 converting into plus 2 and plus 4. Disproportionation. How to find n factor? Just now I told you, use N1, N2 by N1 plus N2. From this you will get n factor. After getting n factor, take equivalent weight equals to its molecular weight divided by n factor. What is the molecular weight given? 55. What is the n factor you will get here? Take it here in the denominator, you will get the answer. Okay, 4 by 5 means you check here. Okay, and next. Can you match this question? Will you try this? Try this once. See, what you know, manganese, about manganese permanganate ion, you know, in acidic medium, what it will do? Converts plus 7 to plus 2 acidic medium. So how many electrons gained? Plus 7 is converting into plus 2 means how many electrons? 5. So what is the x value here? 5. So here 5 electrons plus 2 ion. So it means DT. DT. So DT only in 2 options. Okay. And after that, strong basic medium. Plus 6. Where do we have plus 6? 1 electron plus 6 here. So EU only here. Okay. Now you are going to get something new here. Again, see, mild or neutral medium plus 4. So where do we have? By gaining 3 electrons. Okay. So it means FS. FS. After doing this, you just look at A here. A is Q. It means, see, S2O3 2 minus converts into S4O6 2 minus. What is its n factor? I told you when we are doing that hypo questions. This is nothing but hypo only. So here oxidation state is 2.0 converts into 2.5. Remember this.
Yes.
Okay. And how many electrons here? 2 electrons. Next, S2O3 in basic medium, like B is R. See, it converts into S of sulfate ion. Okay, here 2 is converting into 6. Okay, how many are there? 2 to 6 means 4
8.
to the 8. So n factor will be 8. That's why 8 electrons. Like that you can remember here.
Yes.
Okay, right. Next. Yeah. So still, do you have any doubts or any questions? So, okay, okay, we'll wind up this session first. 7:25.